Okay, today we're going to talk about solving Avogadro problems. But before we get into it, I want to go over some topics here. Things that we need to know to be able to solve these. First, 1 mole is equal to 6.02 times 10 to the 23rd atoms, molecules, or formula units. We also need to know the definition of a mole. A mole is equal to grams divided by the molar mass, or in some other kinds of problems, you see molecular weight. Clues. The term clues means if you look at the problem, what lets you know it's this kind of problem. Clue here is you see the word atoms, molecules, wording in the problem. Now what are the steps to solve? First, we have to identify the type of problem, which would be if it's an Avogadro problem. Second, use what they call GMA or AMG unit conversion method. What does that mean? GMA stands for grams to moles to atoms. AMG stands for atoms to moles to grams. We use acronyms here. GMA really could be Good Morning America. AMG could be average miles per gallon, if you want to remember that. Now let's get to what we need to solve these problems in regards to tools. We need two types of tools. The obvious is the periodic table, and the second, also obvious, is the calculator. Now we are ready to start solving these problems. First problem, first question, what is the mass in grams of 2 times 10 to the 23rd atoms of sulfur? First thing we know, it's an Avogadro problem. Why? Atoms. Second thing is, we do GMA or AMG. Well, what do we have? We have A as in atoms, which means we're going to use AMG. So let's write down what we have. We have 2 times 10 to the 22nd atoms. Okay. The next step here says mole, so we need to convert this to moles. We know that 1 mole is 6.02 times 10 to the 23rd atom. So we put that on the bottom because when we do these kinds of conversions, we always want to cancel the dimension. So we have 1 mole is 6.02 times 10 to the 23rd atoms. We now know that if we cancel this out, we will get the answer in moles, but the answer is in grams. So how do we do that? We now need to go to the periodic table, and we need to look up sulfur in the periodic table. In the periodic table, sulfur is listed as 32.07. So again, same rationale, 1 mole on the bottom because we need to cancel. You notice how these are going to cancel. This will cancel with this will cancel with this, and we've got 32.07 grams of sulfur. Now, you put this in your calculator. When you finish doing this in your calculator, you'll get an answer of 1.07 grams of sulfur. Again, for your benefit, this is all based on these dimensions canceling, so that when you finish, you will get grams of sulfur. Okay, now let's talk about another problem. How many oxygen molecules are present in 0.470 grams of oxygen? Okay, again, we know it's an Avogadro problem because the word molecules is in there. Remember, based on this, atoms, molecules, wording in the problem. Okay, now the next thing is, do we use GMA or AMG? What are we given? Grams, so we use GMA. So what are we given? 0.470 grams of oxygen. The next thing is, we need to convert it to moles because we're using that method. So what do we have here? We have 1 mole of oxygen is 32 grams of oxygen. So that's going to cancel. Now the next step is to convert to molecules or atoms, which means we know and go back to this definition, which is 1 mole is equal to 6.02 times 10 to the 23rd atoms or molecules. Okay, so now we have 1 mole of oxygen here. we have 6.02 times 10 to the 23rd molecules. Again, we put this in your calculator to get this answer. 8.84 times 10 to the 23rd, 21 molecules. Okay, a couple of things you need to notice. 32. You look in the periodic table and oxygen is 16. Why do we pick 32? Because it's oxygen gas. This is a diatomic gas, so we really have to multiply the basic atomic weight by 2 to get this. Okay, that is all for this class.